If you're a future society finding this video on the internet, this was recorded on January. What's the stupid date here? January, Saturday the 13th at 10:42 a.m. Eastern Time. So this is meant to be a trial run of this presentation. So the goal is to get feedback, anything that's unclear, but it's really meant to start to, I would say, put a bow on this first bit of work. And so I'll just jump right into it. Thanks for joining me. Let's talk about strange matter. If you're wondering, before we get started, where this term comes from, there's a theoretical perfect form of matter that should be the most stable thing in the universe inside of magnetars. So, of course, what is a magnetar? A magnetar is a neutron star, so the kind of star you get after a supernova, where the star isn't big enough to make a black hole. And the reason I picked magnetar as the place I post videos is simply because it was a nice analogy, and I like space stuff, and I'm a nerd. So the idea that you blow something up, but it comes back together in a more dense, concise form, versus blowing something up and it disappearing and destroying itself. That's the analogy. It's over the top, but that's the way my brain works. And so the idea that strange matter should be, well, what's the way you should think about solving the industry problem? And to me, we have a need for a perfect is never going to happen, but something that's much closer to a better way of representing data to solve real problems we have. And I'm just realizing this is not centered on the screen, so I apologize for those of you that are annoyed by that. So let's get started. V1, history. 3 or 4 years ago, at the beginning of the pandemic at this point, I guess that's 3-ish, I started to try to figure out what are the big picture ideas that are a challenge in our industry. And I work at HOK, I take part in Building Smart, and I'm very much sort of aware of the work of Patrick McClamey, which was basically the McClamey curve, this idea that we need to move effort forward so we can make decisions faster is basically what the idea is here. So the way this sort of laid out is this is what a typical project timeline looks like. I'm adding the word effort to this because I think it's necessary. And we want to move to that dashed line, and simultaneously your ability to make change without huge cost impacts goes down, and the impact of change goes up. So the later and later you make these changes, the worse that is from a financial perspective, from a change in other areas perspective, when it people's efforts and so forth. And so my investigation was starting with a very basic question. Well, what is this curve in the design of a building, construction of a building, you name it? Well, I just sort of say, well, that's effort, and effort at this stage, my analysis was actually based on two simple ideas. That one, there's decisions that need to be made, and then there's the separate task of once a decision is made, oh, we're going to use this door, we're going to use this facade, or we want to evaluate these kinds of glass. The second part of that, and the most time-intensive piece, is the implementation part. That today, that's often software, it's digitally. And so that's actually the best way at the time, I thought, to look at this. And so I actually said, well, our process to really looks something more like this. We start early and end late. And it's actually much further down the chain because change is continuous, because schedules are compressed. We actually have a starting curve that looks something like this. So my first instinct was say, okay, what do you actually need to do to address this? Well, I need to say, well, drawings take up a big chunk of time, so if I'm trying to sort of simplify the end, this is where you would start. If I was then going to go to the next sort of piece is, well, knowledge reuse. I particularly work for a big firm, but the amount of knowledge we have compared to our ability to apply it quickly is hugely different. AI is starting to open up this conversation, but the idea that there are a lot of new ideas that happen real quick, but we don't have a real great ability to reuse the knowledge we have. So that's a next idea. How do you reuse that knowledge and information you've sort of generated previously? And that would help us bring that curve back. And then finally, a less specific and certainly not technical view of the world, that our models are pretty dumb. And this is just to say that our sort of geometric models, Revit, Rhino, ArchiCAD, what have you, they have the result of the decisions in them, but they can't ever tell you how, if they need to be changed, they would be changed. So we don't have conventions, tooling, and so forth to say, well, if there's a needs for a field change where a wall shifts, can I just ask the data, how should I change? Could a sub ask the model, well, what can I change? Still want to validate that with the design team, but the idea that the rules are communicated along with the result wasn't the case. And so you got these pieces, and if you thought about solving those particular things, you could really bite off a lot of interesting time spent and start to influence this curve. The last one was the term I used a couple years ago at the presentation at NextBuild called lazy data, which was basically this notion that our data is the most chaotic thing we have. It's communicated all over the map. There's different formats, tools, APIs. So like the setup and movement of data is a very expensive part of our process, both from a time management, finding data, what have you, you name it, it's hard. So my response to lazy data was actually this idea that, well, what's really the root of this problem is our data is typically stuck in tools or formats, as in a design tool or a format that doesn't give it up. And so the actual solution to this problem, the first part of the solution to this problem, was to do the work of getting the data out in small pieces out of the tools. And this was a stolen idea that basically said that this is where all the inefficiency is. We do all this work of sort of hauling the data out of applications. This could be manual, could be automatic, but at the same time, what we're often doing is sort of excavating it from one piece of software and then just throwing it down the other. And this idea that doing this is not necessarily a problem. It's the fact that so much knowledge is lost along the way because each one of these tools only cares about what it cares about. And that is a problem because it means you can't skip a particular product. And so every time you have a new product, you have to sort of reimagine and solve for another hole that you're a chasm, whatever you want to call this, of lack of interop. So this is an interoperability problem, but it's actually, I think, much more deep that it's a functionally, the problem is we look at tools and formats being owners of information versus actually, we should think of them much more like producers and consumers, and not owners. So the natural thing to do is to look at other industries, and starting 2016, 2017, 2018, you started to see the sort of USD becoming a more mainstream discussion topic. So universal scene description. This is a format that comes from Pixar, but basically just does this, what I'm showing on the screen. It just says, actually, the way you solve this problem is to take the data from the individual tools that make it, and you use and I didn't use the word bridge at a time, but you sort of put it external in these small pieces, because if you can do that, then you can configure it however you want. And it's not should not be thought as uniform. I'll touch on this a little bit later, but these are parts of a whole that can come from different applications. Whole as in a complete representation of something, and I'll talk about that in a little bit. But this is a very good pattern, and when I say it's not just one format, USD was developed, but there's all kinds of other projects that are forming around it that are specific little representations of some of this information. So let's be a little bit more specific. A timeline across a movie is a shared concept that many tools need, like shots need it, rendering tools need it. So an open timeline would be a way to sort of share a timeline in a distributed fashion across a bunch of people, such that it's available to all, but managed in one way or several ways. Lots of ways of doing it. But the point is, it's the solution to this problem is not a one format to rule them all. It's a way to sort of put all this data together. So it's instructive. We should start here. Let's do that. I did some work to illustrate how to take examples of getting just the little individual pieces out of Revit. Showed some demos of that 2 years ago. And then last year started to talk about this idea of what strange matter actually was. And I hope by this end of this presentation we get a feel for what the actual solution looks like, what problems it's starting to solve, and that we sort of graduate from talking about what the solution looks like to working on getting it done. So, simple example here, just happens to be a residential building under construction in New York City right now. I think there's a very naive, from a tooling perspective, I don't think that anybody that knows the building process doesn't think of it this way, but this is how our data and tooling is represented, that there's basically a process that these things get built, and what basically is happening here is we have a design and construction process. Design data flows to construction, it gets built, done. Overly simplified, but from a software perspective and a data perspective, it's actually spot on because it's so rigid. It moves in one direction well. If you try to go back the other way, it doesn't. Anybody that's ever tried to do, as-built models from a design model based on field conditions knows that there's no good way to do this besides just spending a lot of man hours almost tracing a model. Now, certainly you can do point clouds and these sort of things, but this is a one-way process as represented in our tooling today. But in reality, everybody if you take a step back and conceptualize this, let's just talk through what's happening here. So clearly early on in the design process, there's a notion of what the building looks like. There's going to be a floor. It's got a very basic representation. Later, the architect and the structural engineer sort of simultaneously own the floor slab definition, opening definitions, coordinating it, but depending on the project type, location, and markets it's being delivered in, ownership of this individual opening, or these individual openings, or the stair and elevator openings versus penetrations for mechanical systems might be owned by different parties. Not something we can manage today. And then finally, the sort of complete version of that could be sort of owned by pieces of which could have been owned by architect, structural engineer, fabricator, concrete trade, you name it, carpenter union for formwork, you name it. this is actually what the sort of life cycle of a single slab looks like. But we have no way of thinking about it as it's pieces of information, not the whole slab. And that's on top of the fact that the geometry is one thing, but like the performance criteria, like what's the sort of acoustic requirements if this is a non-residential, are there specific places that the slab needs to perform in a certain way? There's design criteria, that codes and standards. There's contractual requirements that certain information needs to be delivered by a certain time. There's quantification and cost. And I'm showing these not because they're like all the things you do with these 3D representations. They are literally part of the slab. Like the cost of the slab, the quantities of all slabs, the requirements for these slabs, the criteria, they're really just different definitions of the same thing. And then finally inspection criteria and so forth, handoff. And so this idea that the geometry or the cost data or something is somehow broken up into different pieces and different softwares, and the work of a human in our industry is to conceptually put them all back together while we work, is extremely challenging. And that little cube animation was useless, but nice. So really, there's a very simple thing that you learn when you look at this. I showed this diagram of getting the data onto this sort of bridge-like thing a few slides ago. You actually need to get it out into smaller pieces, and these pieces need to be such that you can decide who is going to do what on a project like this. So if there's multiple companies involved, if there's multiple pieces of geometry. So this idea that in a software terminology, sort of object-oriented programming, so this is any of the software we typically use today, like from a modeling perspective, certainly thinks this way. Think Revit, ArchiCAD, and so forth. The idea is that in an object-oriented world, the software owns the whole thing. Like conceptually, you hit export, the whole slab is coming out of the tool. And if you have like a trade model, well, those are actually just two slabs, and I have no way of putting them together. Versus the term I'll introduce, and I won't spend too much time on it, that comes from the game industry, is an entity and component-based approach, which you compose the data. So a composition model versus a sort of full object model is that you have an entity that says, well, I'm the identifier for this particular slab or set of slabs that share a lot of traits, and actually each one of these pieces of information is just a component. And this component number 4 and component number 3, you can make tools that, if they need to be coordinated, like the quantity component, and quantity not as in count, but quantity as in like cubic volume of concrete topping here or something like that, and the cost. If they need to come together to form the, a unit cost plus a quantity need to come together to make a cost, then, well, they need to be coordinated, but it could be that the quantities come from one entity, cost comes from the contractor, and the calculation is done in a sort of via algorithm. It's not done by a person. But this is the fundamental takeaway that, you not only need to get the data out, you need to get it out in pieces so you can break it up. And these pieces need to be well-formed, named. And so you can say, who owns the fire rating properties? Not, I don't have a good name for it, or who owns the cost data, or who owns the sort of specific quantification. These are named real-world concepts that we deal with every day, but we just don't have a way to sort of conceptualize. And I forgot that animation exists. So going back to that key idea, this is a map. So I showed the USD slide from the ASWF, the work that Pixar done. You end up with when you sort of start down this path, you end up with an ecosystem of solutions. So some formats, some tools, some standards, but the idea is breaking the data up makes unique solutions possible, unique standards possible that solve specific problems. So today we're sort of in this place that we're looking for this mega format to boil the ocean, but really what we're saying is we need a way to put all these unique, probably not the same or different representations of the same information. We need to figure out a way to put them together, and such that you can make real workflows that they're like a computer can understand it versus a human have to do it. And so this is really what you end up with. And the key thing about this is there's a really nice things that are emergent when you start to do this. You can do things out of order, which is unbelievably powerful once you wrapped your head around it. So I mentioned earlier that knowledge reuse is quite hard. Well, what if a construction company knows their unit costs, not in somebody's head, but they have a sort of, and this is big construction companies do this all the time, they have unit pricing that they continuously up to date based on market conditions. Well, what if I already have my concrete in this market, in this kind of use case, cost component? I never have to develop it new, morph it. What if it was just sitting in a library, and then when the specification came out and the geometry that I could extract the quantities from developed could be in this order, I instantly have the total cost of that particular work breakdown item, right? Because if you are able to represent the data independently, you can make a very simple tool that says, well, find all concrete component entities and assign the cost component and do some math. A computable environment that can be done out of order, that you can, I'm showing this financial example from a construction company, but standard details. If you pick this concrete, this is the detail, versus, well, yes, you can have the detail, but do you automatically know it comes with the information? Or obviously carbon is something that people care about. Right now we sort of have, well, you can collect the standard information in a database, but you sort of have to sort of transform it as you use it on a project. This approach would allow you basically just to put the data in a soup, if you will, and apply a very small amount of compute and get things in real time. So the real learning here is this sort of objects to components. It's actually not that complex. There's a little nuance to understand here that the entity is just like the conceptual idea identifier. A floor slab is a thing. It needs an ID that all the other things can point to, but each one of these things can be standalone. They can be coordinated with software, but if the architect owns component number 2, a contractor can own component number 5. And there could be components that the architect, engineer, owner have that the contractor never sees, and vice versa. This is the point of a model like this. So I always sort of assumed this existed, but I never thought to look at it. This terminology called information logistics. It's actually very logical that there's a kind of thinking that we have not really done in our industry. We think about tools, often, like my application, and then we think about other pieces of software that move the data those tools produce around. And then we think about, skills and processes and developing new data and speed by which we develop the data. What's interesting is I don't think we've ever thought about, well, how do you get the benefit of the data itself? And to me, this is what this is really turned into. So I had this early notion of effort equals decision plus implementation. I actually was wrong. It's decision making and implementation, but because we're a networked industry, where no single entity ever can do a whole project, we actually have to care about the network efficiency. And this is where this really stands out, that there's in turn, form a value-creating network. So the idea that the connection between the data points, between companies, between workflow, between softwares and stuff like that, in and of itself is a valuable thing to focus on. This is straight from Wikipedia. I'm not inventing these things. I had notional ideas that this is what to say, but it's actually the most concise way of thinking about it. Creating the data, important. Quality controlling it and so forth. Is it the right data? Implementing it. How do I get it built? How do I get it procured? Those are meaningful things and important things to know. But actually the network is where all the value can develop that increases the effectiveness in either one of those. So what we have, sorry, this is quite bright, is a data logistics problem, and the sort of the very real world example from the logistics world is the container. So you can see where I'm going with this, that actually what we need, that little component I've been describing, is a sort of a container of information that can do certain things, and we put them together. So I might remove this slide. So what does a container for AEC actually look like? What does it have to do? How does it work? So let's think about what we're saying here. So if a container is in the shipping context, is a product of some sort that you put inside the container, and the product has all kinds of information inside of it, but the container does too, because actually what we move around is the container. We don't move around the product. Very, exactly what we're saying. What we want to do is have a common way of identifying key data, well-defined data. If this is a car or, jelly beans, the container is the same. We need to know where the container is, where it came from, and so forth by this identification. And then there's a whole other series of information about the things inside. And sometimes you want to share both, or sometimes you don't. But it's a very instructive way of looking at it. Well, so what we need to do is design, and this is what the work of Strange Matter has become over the last year, is, well, what are these components? What do you need to put a single bit of data produced by someone, put it out in the world, such that if it's found, you both know what's inside of it, and inside is a very meaningful way to think about it, where it came from, what it represents, stage of the project, version, you name it. Could be sitting on a proverbial data shelf, like in a file system somewhere, could be in a database, but you sort of have to think that the component needs to be functional by itself. So that's basically the work that I've been working on a GitHub site that I have the link at the end of this. Like, what is the specification for the container, this component we have? So I won't go through this in detail, but like, what's the equivalent of this information? What am I? Where did I come from? What's the information about the thing inside the container? And then how do I track, where this is, the logistics, if you will? And so this is public website. Strange Matter protocol is there. This is the work of the last year. I'll point to some of this, what it looks like, a little bit more detail, but the highest level idea is that really we're taking this data, we're first getting it and breaking out from monolithic files, but really what you need to do is go from monolithic files to these components, because if you do that, you can do some pretty amazing things. So the way I'll talk about it is that you actually, to replicate the container analogy, is you actually have a header, which is sort of the thing on the outside of the container. What is the container itself? Where did it come from? And so forth. And then you have the things that go inside of it. So just like the VFX, ASWF, Academy Software Foundation example, there are so many things that we do not have standards for that independently making them their own representation, making their sort of data typing and all that stuff would be a task. But if you did it independently without a common way of shipping the data around, it would just make things worse. And to me, this is actually a meaningful reason to point to why we haven't standardized so much, because we have so many things to standardize. The idea that we would have a unique API and all these things for each one of these things is just insane. So instead, we should have this component. Think of it in the container example, the shipping container equivalent of, oh, I don't need to have a unique way of managing, storing, distributing, reading all my data. I have a standard way of doing that through these components. But then inside of these things, in the payload, what I want to do is work on making these data representations, inventing them if they exist. We don't have a common time format. We might have something that you could easily nominate as a standard from sort of some of the work Oracle does, schedule and so forth, or Microsoft Project, but we don't have one. Issues, we sort of have a generic one for models. You get the idea, but by focusing on the component first with an architecture that can put anything inside of it, it's so much easier to think about making a tiny little standard that distributes cost data, because I don't have to do all the other work. And this has very, very good parallels. Any software developer will laugh, but this is the layer OSI model, layers because it's built up of how the internet works. So imagine an internet where email needed its own internet. This is roughly where we are in the world. So what this approach is saying, well, actually, storage, where you put stuff digitally, is sort of an infrastructure layer. And this component and entity layer, the containers I'm talking about, is just how you move it around, how you talk to it, how you identify what it is. And then finally at the top you say, oh, well, there's certain data inside these things that I want to talk to. No system would ever talk to all components, or all containers in this example. That's perfectly fine. That is a very reasonable thing. But it enables some very interesting ways of working and solves a lot of real challenges. It can solve multi-owner because, as I described, the idea that sort of different pieces of information get developed by different parties. Multi-application, same party, let's say an architect, I'll show you an example in a second, but I want to use two applications that are good at different things. Impossible today. Helps with contractual boundaries. Instead of one party have to because they own the, say, this is a place that's a very good example, like asset data. Well, a design team owns a design model during construction, but client wants asset data on it. That is really hard to solve because in reality, there's already most likely a trade model for a lot of these things, and the current best solution we have is to put it in either one of the models. There are some solutions that are appearing to sort of realize that you put it outside. It's instructive that they are appearing because they are doing exactly what we're describing here. It's just that we need to sort of think big. And then machine-to-machine communication, and I'll talk about that in a second. So let's take, I missed this line here. Let's imagine I have a pipe and a beam, and when we say something clashes, we're not saying that the property sets clash, right? We're actually saying the geometry. So the first thing you might say is, well, let's make a simplified web view of this data set. So GLTF is what I'm pointing here. That's the sort of, if you will, the JPEG for the web, for 3D data for the web. So instead of doing what we do today is, well, I have a clash and I get some IDs, and I might be able to sort of make a unique data set that has to be moved around uniquely with its own standard of APIs. Well, actually, this is just a relationship. And this is part and parcel of this approach. You have relationships between unique sets of data. So I've made a clashes with relationship, and the second you do that, and that these could just be stored in the same big bucket that you put permissions on, and you determine who can see each one of these things. But you could put an ML model on the data set because it's connected. It's describing itself. If you do this manually across projects, maybe the solution is a move. What you're really saying is that by having this connection, you would get a history of, okay, this clash resulted in this geometry being transformed, and you do this over and over again. You could come up with an algorithmic approach that just automatically does it, doesn't have to use AI, or you could have an AI approach that trains on it. But the meat of this is by making data that is standardized in its connectivity, but doesn't have to be standardized in its format. You can do all kinds of unique things. Like it could be that a clash tool has no idea how to read any of these things, maybe a property, or can't read a requirement, but it can read the classification. That is totally fine, but the point is that connectivity is the important piece. So let's talk about a very practical example of one entity, two softwares. So, and I'll be specific, there's a couple softwares out in the world, Kanoa being one of them, that look very attractive. They're trying to solve a simple problem. How do you make the layout of furniture an attractive, easy to solve problem and link that to products? I look at a software like that and say, okay, that would be great if we could use that in our process. So what does that software do? It's doing relatively straightforward things. I'm being overly simplifying here in this example. This is not Kanoa. This is just me making something up. So what does the software do? It picks a style of chair and lays it out on a floor plan, let's say. What's happening today is basically we were forced to make this choice. I can do one of two things if I have two softwares, one that only lays out the furniture and another sort of full BIM tool, if you will, that can do everything else. Well, today if I do this, I have to make a choice. Stop using this software because I'm fully transferring ownership to the other one because I can't partially transfer ownership. Or I just have to live with two copies of the data and then do some sort of manual coordination afterwards, which is gross. And so I think from a lot of perspective and a market perspective, this is keeping adoption of new software tools, not replacement necessarily. There's just like better ways to do small parts of things. And in reality, we have these big tools that can do a lot of things. They're not going to be quickly replaced by anything. So you actually need to support this model. Advancement will come here, but I still need this one, and this model doesn't support that. So in reality, what we need to do, and I'll fix this here, but it says 9x, is we need to break, if we take this model of saying, okay, when I export the data from this application, externalize it, what am I actually doing? I'm exporting the style, location, geometry. Those are three separate ideas. There's three separate pieces of data that this tool creates. If I bring it into the next tool, I reference it in. I don't fully replace the data that's already out there. I make maybe a new representation that's the one that this software likes. I add new information, and I then export that and make a combined collection. So these tools become editors. You assemble the data externally, and now I have multiple things potentially coming out of these tools, which is absolutely fine because this is like from a stealing ideas perspective. This is exactly what you do in the USD space. You decide which pieces of information are expressed on a stage or something like that. So there we go. There's my chair. It's a collection of information across multiple tools. And certainly you need to, like if I have material information, like what it looks like visually, and geometry, and I need to make a check that they're compatible. That's obviously something you need to do. But that's the compatibility check I'd made. There would be no point in having a check that looks at everything, because there isn't potentially a canonical chair in this, because, well, the cost information isn't here. The actual product with the sort of purchase order isn't here. So we would check the individual pieces of data are complete, because what you'd want to do then is be able to share a subset of that information. And again, the text here needs to be fixed, but this is a simultaneous design and construction. Design team, CM. Excuse me. So, by sharing property, location, and geometry, what you might be able to say is, well, contractor has what they need to start a procurement process, because it's what, where, and how many. And functionally, only reason you'd really need to give geometry is to show what it looks like, but that's fine. So you can have a furniture procurement app that comes along and looks at this data when it comes in and says, okay, I have a database that has the product data, I have the cost data, and then I could come up with a procurement process, and that could be done manually, because you have a trigger that just says, well, I got these 3 things, now I can do this task. So helping people do their work by basically giving them hints that you have all the information you need to do a task. And that would go both ways, because the design team could know, oh, I've satisfied enough of the requirement at this point in the project that they can start this process, and they don't have to keep necessarily asking, because that could be better than internal tools. It could be functionally written into an algorithm that says, okay, this is the procurement process we're going to use for things in this project. I'm showing a very small example that maybe you wouldn't write specifically for each one, but the idea that you need certain information on certain entities would be absolutely worth the investment if you could reuse it. And this is how you start to reuse it. So you play this forward, there's some changes. The point of showing this is not because you need software that can make changes. Obviously that's important, but that the changes are non-destructive. Because if you break things, because if you have full ownership in a workflow today, you're breaking things. Here's the new data that replaces the old stuff. We're not replacing anything but information that's changed, because this wants to be immutable. So I actually have a new version of the locations. Here's the updated locations. None of your data here is affected. None of the other data would be affected. And then frankly, when you go to install it, if there was a reason to, like, from an asset perspective, track the locations differently, totally plausible. At that point in time, the location data gets updated and handed off to an asset system. So that's we stop here for a second. This is the kind of workflow that this approach to data enables. So if you break it up into pieces, sort of from files to objects, and from skip the objects but go down to the components, you could do workflow. Now, it's obviously important to think about some of the sort of other advantageous things. I made this example to show the use of a furniture tool that would be hard to integrate into workflow today. But you can imagine all kinds of different tool approaches. That was just listen to a podcast with Aaron Perry and Andy Watts from the Troxel podcast, and this democratization, or I'm going to blank on the term, but this idea that data is much more accessible to people that are experts, that have a small part of the solution. They don't have to get into these huge tools. This is where stealing some ideas from the software world makes sense. So what I have here is a mock-up I actually did 3 or 4 years ago now, because I didn't understand how to do the data yet, but I knew the tools I wanted to get to. So the entity component, the strange matter approach, was born out of, well, how would we actually want to work? So this is an example of how do we want to work, and how should the data work in that way of working. So this is an idea of stealing some of the, if you will, visual paradigms from Visual Studio Code. So Visual Studio Code is the tool that, it's the most generic one of software developers use today to build applications. And the way that works is the code exists typically in a Git repository. It's copied to their machine, and when they want to work on pieces of it, let's say the specifications or something like that, they load it up, and they can put like 2 bits of code next to each other if they want to compare things. The data over here might be referenced into this data, and it's a paradigm that I thought made a lot of sense. So I had this early idea that, well, what does this look like? I have a bunch of resources, so company resources, project resources, individual applications that, this might be the right list. It's certainly not, but it was an early attempt. And then they have these different data sets that are here. Again, this was developed before this and the component approach, the strange matter approach existed. But the idea that what I would actually be doing is making tools that brings these different pieces of data together. So the first sketch here is like, what would a library application look like? Well, today we have tools that have like, well, here's the Revit content, here's the, sort of maybe Rhino content or SketchUp content. Well, actually, those are just the same potential object with different pieces of data that describe it. So a door here in a library would say, well, the entity is just this generic representation of the door. It's got some material information. It's got associated details. It's got typically associated hardware. It's got links to the products that actually satisfy that. It's potentially linked to the projects it's used in or the specifications that describe it. So the idea that if I were to, I'm going to skip ahead here, use this door on a project, I actually already have and can reuse all the knowledge I have automatically to say, well, in the library, the relationship, the door was made up of all these things. If you need to make a drawing that has the details on it, I 100% know about those already. You don't have to go find them. Or, what is the specification for this? Add that to my project. By making the data broken out in these pieces that are of different representations, you can automate these things. So if you think on a typical model use case, I have a application on the left, which is a subset of the model. So walls and rooms, the geometry and the locations. Because that's maybe all I need to do the task on the right, and I think you would need more, but for illustration purposes, I want to add the code information to the rooms. So if this data is outside of the authoring applications, up to date and versioned, then I can add the code component to the room. These are the same rooms. I should have drawn them as such, but there's some properties over here, there's geometry and locations over here, but they're the same entity. And I'm just adding the code data, like the occupancy information here. So versioned individual component geometry, versioned individual component properties, 2 interfaces, 2 applications allow you to edit the data that's shared across the rooms. So what does this start to look like? We have the components, we have the sort of definition of these things. This is what the sort of the world around this ecosystem wants to look like. You'd have the specification for how you make the components. You'd have a standard API to say move them around. How do you know what's inside the container, the components? And maybe we should actually just change it to containers because it's a much better analogy when you think through it. But you need a standard API specification and a protocol. And the reason that I use the word protocol in the GitHub site is something that was passed along to me by Shane Berger, which is protocol is the complete thing. This is how you use it. Whereas an API can be a subset. And the key thing to this is that a container, when it's shipped around, you don't get to like, let's say that a container in a ship, you truck it from the factory to a port to the ship. You don't take stuff out and manipulate the data inside in each one of these steps. No, it's solid. You can look inside of it, you can understand it. And so it's important that this is what you do with the components when you put them in a software system like a CDE or a Git-like system. That has to be well defined, and so you're not losing data by putting them in these things, but that you can reuse them whenever you want, and that the API then builds on top of that to say, oh, here's how you transact, here's how you get all the components that have cost data on the walls, or here's how you get all the occupancy data, or here's how you add all the occupancy data, what have you. So the idea that this can work on a Git-like system, a Speckle-like system, a vendor CDE, or new products that want to get developed, this is the evolution of these ideas. So finally, it's always good to make sure coming back to this isn't at all about just geometry. So let's talk something like materials. So that concrete, like this is a perfect example of very distributed topic. And we have a specification and all the testing criteria. We have a specification app and a material app that you do things like catalog all the requirements. Same exact idea, but that same material could show up in a visualization. And again, you're just swapping different apps that look at different subsets of the data that different people can own. Not to say this app owns them all. Maybe this app, all you're doing is coordinating that you have the right, maybe these two apps, what you're doing is coordinating that my spec, my visualization that I'm showing to a client, and my supplier and cost and carbon information are aligned. And this is just the UI that helps you do that. So you could make an example list of apps forever: door hardware, life safety, spec model linking. Literally, if there's a small bit of information that needs to be addressed in a certain way, this is the way to you definitely do that. So Strange Matter Protocol is really what I've been working on the last year, really and that's why I've been relatively quiet. So the software specification that came out of the UK, they use this term bridge, and that's what I'll use going forward. So this is this product that stores all the stuff, and I've not spent much time on that. Obviously, I have viewpoints on it, but that's something that has to be figured out. What are the right ways to do this? Functionally, I think this wants to be many things, not just one. So it can be distributed, but the distributed systems all work the same, but they don't have to be the same products. It can be open source, closed source, you name it. But that's why the protocol exists. So you have the protocol, and then the piece that notionally it's clear is necessary is the API that says, how do you talk to these independent systems about these little bits of data? So because we have this component, we need to put stuff in it. In the last year and a half, been working with Building Smart to look at what future version of IFC that we're calling IFC 5. How do you put IFC in a system like this? Because you have to do that if you want it to really work well. Clearly, you can put PDFs in a payload, and just like an email, which is a very good example of a distributed system that works the exact same way. Like emails are routed. You could put anything in an email. A component should work a certain way, but if you were to get an email that has a certain attachment on it, you can make rules that know what to do with it. Very similar ideas. And then you can actually respond to bits of data like you do with an email. So you do have to adapt it. So that's the first place we're looking at it, but I'm working on experiments of like the door hardware tool would be a perfect example of doing something like this today. But there's so many to do. It's really just, can you start to look at where should you spend your time and focus? So the status right now is the specifications for the components is pretty far along, and it certainly can be optimized and cleaned up and use some care and feeding by testing in software. But based on how far we are today and need to get into a much more robust implementation and testing regime, it's pretty good. Serialization, start with JSON, we'll go from there. The individual formats will have their own serializations. Perfect. Typical and repeating workflows, like how do you, I have 100 columns, they are exactly the same. How do we repeat that in the data? Work in progress. Collections and archetypes. So a collection is sort of the thing that replaces the file, which is to say, oh, here are all my pieces of furniture in my furniture example. And the three, the location, the geometry, and a property. We still need to have transactions around those things. We don't just make data and it just flows over the fence to parties. We're a contractually separated industry, so we need to think about those things, and archetypes are really just the idea that what does the complete chair eventually look like? That's a sort of concept we need to think through. IFC in strange matter is moving along. It's not formalized, but we've done a lot of work over the last 2 years to really get buy-in from the community, and I would say it's been quite successful that everybody's on board. There's now we're at the point where we need to sort of put it into testing software, but and test data and testable software. And then there's other standards that have to be looked at into strange matter. Like I've done some prototyping of different properties of how you put GLTF and so forth, but again, these are just work in progress. And then the API is one that everybody agrees is the place that this needs to go to, but hasn't really been started. So this work has all been happening sort of in a sort of Greg at the center, but not because I'm the most important bit here, but it's a coordination effort. So what I just described, vendors, and it's safe to say that all the big vendors are working on systems like this because they understand that this is a better way to handle data, and frankly, the use of an entity component system is something I learned from Autodesk because they started to talk about in their data exchanges, and I'm like, oh, that's what this is. So I've been coordinating with them, some directly via Building Smart, but some also that are just working on the sort of the raw data architecture to put anything in the components, because this is the important thing. Anything can go in a component. You could have components that are binary data, so not text, let's say, that you can never read, and that should be perfectly fine. Just like you should be able to put something in a shipping container, send it across the ocean, and if whatever regulations are met, you can't know what's inside of it. Perfect. So I've been coordinating with at both levels through the IFC piece, working with large companies about at least talking about these things, and I think we're at a point now where we're going to actually start to fund through some efforts we have together, fund prototypes to start flesh this out, and these need to be open source. This is part of the reason this has been delayed, is that I need to make sure that if you're going to do all this work, all of it needs to be open source. Tools built on top of it, that's a total different discussion, but the actual libraries and everything else that standardize the data, talks to the data, the APIs, needs to be open source. Open specification group, certainly I'm talking to, but not necessarily a part of the full specification, but the how the data works is certainly something I talk about, and then obviously the Building Smart perspective of, okay, putting Building Smart in the IFC data and actually there are other standards in this structure. But it's actually a very, very good time, but I think in doing this process, I've identified a few gaps that it's interesting that this industry doesn't have. So I'll call it computer science in AEC, but there's this in the game development and graphics world, it's a big industry, but it's much smaller than construction. There's a conference called CGraph, and so this idea that there's no CGraph in AEC brings to the surface that we don't have a lot of sort of academic involvement of solving this kind of data problem in our industry. And I understand why, but it's something I think is very interesting to talk through and figure out. And then, frankly, there's the Metaverse Standards Forum, which is trying to do standards coordination in USD, which is also becoming more standard. We should not look at these as competing efforts. We should think about how they would come together. But I think the most important bit is the stars are beginning to align. Vendors are already moving this way, like I said. Whether there's publicly facing stuff yet, I'm coordinating with, so system architects in the bowels of these big companies because they're working on these things simultaneously. It's not a solved problem, so let's solve it. When we're ready to be public about it, let's make sure we're moving before we're ready to move it. Before they're ready to be public about it, what can we do to coordinate it so we're aligned? And that's the work I've been doing with them. All of them thus far have been said they want to do this in an open way. They want to do this with open standards, make new groups of standards bodies to help coordinate, like across all the disparate standards that are owned by different groups. Some of this wants to be more sort of web standards for just probably the container itself versus like the data standard, which is a Building Smart example. You get the idea. Firms are coming together. There's consortium of firms in the US working together. I've worked with the Open Letter group and firms around that on my trips in the UK. APIs are early and just getting started, and this is an important thing. It's going to take a long time to get the APIs right, so we should start working on them now, but start working them on an open protocol. And also, compute and AI are really starting to come together in the fact that, like, the way people are handling data works really well with this approach. AI tools will be, it's very easy to understand how an AI application could make new components by looking at the other components. It's a pretty useful thing. So I think I'm very excited that now is the time to do all of these things. And like I said, the reason I picked this sort of magnetar at the beginning, it's a rather poor representation from Dolly, but the idea that we need to blow our industry up, but we don't want to blow it up so it breaks it. We want to blow it up so it brings it back together. So I'm really quite excited. Like I said, I'm trying to make this sort of think about this as a graduation from figuring out what to do to let's start working on it kind of discussion. So I really appreciate that. This is the end of the sort of big ideas, what needs to be done, pitch piece. One last thing I'll say is if you feel like contributing, there's definitely a GitHub site that I'm tracking all these things. We have a wiki page that any of the feedback that I'm getting, consensus, if you will, from inside the big companies or others, I'm tracking these here, such that we don't have to have the big public companies that aren't ready to talk about things raise their hand and say, yes, this is the way we should do it. But these are the kinds of things I'm starting to track, and there's probably things I can add to this list. The specification itself probably needs some love, but I continuously work on it in spurts. But when people ask questions, that's when you get work done. And there's a GitHub site that you can go to and look at. It's open, make comments, so forth. And then finally, if you're interested in sort of doing contributing work, like interested is one thing, and I think that's important, but it's time we're going to get all these groups together, especially at the firm level, because this is the place that there seems to be a new set of momentum there. We have momentum in the Building Smart area, and actually we do with the big vendors, is to start bringing people together that, oh, I want to work on an experiment of this, and I want to test that, and I want to prototype X. There's some of that going on by very few people that are doing a very good job, but these are all the right ideas, and I think everybody agrees with that, but it needs broad exploration, not super focused on only solving one problem. Really appreciate the time. Please provide any feedback or questions. Hell, I might just post this one and not do a version 2. I liked most of what is there and might live with the errors, but if there's anything glaring, anything that's unclear, you think needs more explanation to really understand why this is important, please let me know. Thank you all.